So we're going to be continuing on with the topics that we have on our course resource page. I'll chat that out to everybody. So yesterday we went through part 1, the FME Workbench Basics. If you missed that and want to review it at a later time, we do have a recording of it. I'll paste this out into the chat window as well. That says recording's coming soon, but if I refresh that, there we go. For each day of the course, the recordings should be available on that page about an hour after the course completes. Yesterday we went through Workbench Basics. There were two topics yesterday that we didn't quite get to. I just want to quickly go over those now. They'll just take a moment. The first is updating reader and writer feature types. Sometimes the source or destination feature type definition, which you want to use, may change. That can be because the source data set has changed, or because the requirements for the destination have changed. This is yesterday's exercise, where we are reading in a parks data set. If I double-click on this feature type, you'll notice that I'm unable to change things like the table name or the attribute names. These reflect what's in the actual data set. If I want to update this feature type definition, I have to tell FME to reread this data set and find the current schema. That's fairly easy to do. There's a number of spots in the interface that allow you to do it. With most things, I usually start with the context menu. In this case, it's not in the context menu for the feature type itself. But if we go to the navigator and right-click here, there is an update reader. And that will allow you to select an updated data set and update the feature types. You can also find this functionality under Readers, Update Feature Types. So when I select one of these, it'll prompt me to select the new data set. This is just demonstration. You don't have to follow along in this situation. What I'm going to do is actually update it from my destination feature type. So I'll grab that, hit OK. In this case, it's telling me it didn't find a match because I don't actually have that particular feature type. I guess that example won't work for me. But when you go through the update, it'll find what attributes are currently available for the feature types that you have defined on the canvas. I'll just quickly send this one out to Parks. There, now that I have a matching feature type, I should now be able to do the update. There's my parks. It has a different attribute list. You'll find these attributes change when I hit OK. So now I have that updated attribute list. You can also do the same thing for the destination. This is often useful if you're writing out to a database. Perhaps the database definition has changed. We can go to Writers, Update Feature Types, and then point to the updated database tables. And that will update the feature type definition here. So that's updating your reader and writer feature types. And as Mark just pointed out in the chat, this is important to know that you will be using this in the utility network migration workspaces. Something else that you'll find in those workspaces are junctions and hidden connections. This is relatively new functionality for FME. Sometimes the connectors that you might have a lot of them that all connect to a single transformer or need to go far across the workspace. Those connection lines can cause a bit of clutter if you have a lot of them. What you can do with these connectors, if I right-click on it, there's a number of options here. I can hide that connector and it'll look like this. So now I would not see that connection line going across the workspace to some new output. I only see that connector if I select the source or the destination, the output or the input transformers or feature types for this particular feature connector. The rest of the time, it's hidden from the interface. If you do have a lot of hidden connectors, you can actually see all of them by selecting Control A or pressing Control A. That selects all the features on the canvas, and because those transformers are now selected, you'll be able to see that hidden connection. If I want to show the connection again, I can right-click and show connections. Another way which I can hide this is to convert it into what's called a tunnel. So I right-click on the feature connector and there's this option here, Create Tunnel. It also hides the feature connector, but in addition to that, it will create these junctions. A junction is basically a transformer that does nothing. You can connect things to it, you can have things come out of it. What's nice about this tunnel is that we actually get this little bit of commenting. For best practices, this is really useful. So now I can see where this is going and where it's coming from. My personal preference is for these tunnels over simply hiding the connector. These junctions are also really handy if I need to connect a number of feature connectors together and then have a single connector go from there. So you'll often see these junctions being used as placeholders. This can be handy for organizing your workspace, keeping it tidy. And you'll notice that we can also use the feature caching with these junctions. So sometimes if you want to run a particular part of your workspace, having these junctions there so you can run to or from the junction is useful. You can also insert junctions onto an existing feature connector. And perhaps, well, not perhaps, because the junction is also basically a transformer. If I just type in junction, you'll notice that I can drop that in just like a normal transformer as well, and that'll drop in a junction. So that's junctions, tunnels, and hidden connections, and you'll see that a lot in tomorrow's workspaces. Just going to hit Control Z a few times to back up. There. So that brings us to today's session. In today's session, there's a number of smaller tutorials available on our Knowledge Center that I want to review for some specific transformers and functionality, which you'll be making use of on Wednesday and Thursday. Now, when looking at transformers, we have additional documentation in the link here. Let's see what we get. This is a transformers list. There is actually a better transformers list if you're looking to review transformers in general. And I do recommend that you at least read through the names of the various transformers in FME going forward. At safe.com/transformers. And I'll chat this out to everyone as well. So for those of you who are new to FME, this transformer gallery on our webpage is an excellent resource because you can sort by most used. And you can also look at individual categories which interest you. At some point in time, I do recommend reading through, at the very least, just the names of the transformers. The names are fairly descriptive. Transformers which will apply to what you are doing should jump out at you. You can also find additional information about the various transformers we go over today on our Knowledge Center. Knowledge Center is also a very useful resource when you're getting started with FME. This is also a good place to ask, how do I do something type questions in the Q&A forum. Something I want to take a bit of a closer look at is the Attribute Manager and Attribute Creator. Let me just change the zoom there. Looks like I either have this extra stuff down the side or it's oddly justified. So we can use conditional statements in the Attribute Manager and the Attribute Creator. But before we take a look at the conditional statements, I just wanted to go over some of the other attribute handling transformers and when or why you might want to use them. In yesterday's exercise, we used an Attribute Manager to manage the attributes. You'll notice that when you open up the Attribute Manager, it will pre-populate with all of the attributes which are on your features. Now this is really handy, but with some data sets, this can become unwieldy. Sometimes you simply want to add a new attribute to your features. But if your features have a large number of attributes, when you open this interface, you'll have to scroll all the way down to the bottom. And that can be, if you have 100 or so attributes, or even just enough that it becomes a pain to scroll down, it makes the Attribute Manager less friendly. In situations where you have a large number of attributes, another transformer you can consider is the Attribute Creator. The Attribute Creator is really handy when you need to create a new attribute. For attribute creation, it has all of the functionality of the Attribute Manager, but it doesn't pre-populate with all of the current attributes. So I can just go straight to creating my new attribute. If I have a lot of attributes and I simply want to rename a few of them, there's also the attribute renamer transformer. Again, this isn't adding any additional functionality, which is already in the attribute manager. It simply has a smaller list, or it's not pre-populating with all the existing attributes. So when you already have a large number of attributes on your features, this gives you a cleaner interface. So those are situations where you may want to consider an attribute creator or an attribute renamer instead of the attribute manager. Something we saw briefly yesterday is some of the more advanced attribute handling within the parameters in transformers. We have our label point replacer. We could have set the label to be a specific attribute, but instead we used a text editor to create a more complex value. There are some additional options in these dropdowns. In addition to the text editor, quite often you'll find other options. If I go into the attribute manager here, if I'm creating a new attribute, in the dropdown I can see the full list of options. I can have a text editor. This is essentially the string concatenator. It's a concatenator transformer embedded directly into this transformer. For mathematical expressions, we have an expression evaluator transformer, but we also have an arithmetic editor, which is basically the same thing, embedded in the transformer. We can create a user parameter. This would allow you to prompt the user to supply a value at runtime. And finally, we have the conditional value. This is very similar to an attribute value mapper transformer, but it actually has additional capabilities. Conditional values is very handy. It basically performs a test and then supplies a value on the results of that test. So let's take a look at those conditionals. I'll send out a link to this exercise. So we won't work through the exercise, but what we will do is download the template and then take a look at how this particular attribute manager is configured. So you can click on the example workspace as a template. Templates are zipped up workspaces, workbench workspaces that include the data used by that workspace. So we can open this up. Make sure you open it up in the Windows 64-bit version of Workbench. Perhaps tell it to always use that app. I'll also send this out as a chat message. I'm just going to clean up my windows here. I'll open up my translation log. drag everything down to that to give myself some extra space. So we'll take a look at bookmark number 1 here. You'll notice that all of these transformers are grayed out. Basically, this part of the workspace has been disabled. You'll occasionally see this if people are testing a particular part of a workspace. They don't want the other part to run when they run the workspace. So you can select readers or writers or feature types or transformers, and you can disable them. If I right-click on my bookmark, so we'll click on the bookmark, right-click on the top of it. You notice we have this option right here, Enable All Objects in Bookmark. So please click on that and enable the objects within this bookmark. So this will be reading in our parks data set, which we're familiar with. It runs it through an area calculator to calculate the area. It then runs it through an attribute manager. The attribute manager is creating a new attribute called park size. Keep in mind that if we had a large number of attributes here, perhaps scrolling all the way down to the bottom to add park size would be unwieldy. So we could have used an attribute creator transformer instead. It would work the exact same way. For the park size, you'll notice the attribute value here is listed as 4 possible values. A conditional is being used. We can select this, and in the drop-down, go to the conditional value interface. And it looks like this. So we have a number of if, else if conditions. If the value of park area is less than 1,000, it will be given the value of tiny. If it's between 1,000 and 3,000, it is small. Between 3,000 and 10,000, medium. And anything which does not pass these tests will be given a value of large. If I double click on one of these clauses, it brings up this interface, and you may recognize this interface as being the same as the tester. That is essentially all this is, a number of testers. And if something passes the test, it is given a new attribute value. So this is actually more powerful than the attribute value mapper. The attribute value mapper is a lookup table transformer. It will take a look at the current value of an attribute and provide you with a new value, but it only looks at the value of one attribute. This particular option, the conditional values, allows you to do any arbitrarily complex test. Basically, look up multiple attributes and assign a value from there. So you can see here with the small, we have multiple tests. So a little bit of discussion of the functionality here. When the features come in, they are tested in order. The first test they match, they'll be given that value and passed out. You will not end up with duplications of features if they pass multiple tests. The tests are done in order. The first test that matches, that's what it goes out through. For example, if I edited this test so that it's less than 1,500, and this one's still from 1,000 to 3,000, Something which is 1200, technically it would pass both of these tests, but this one is first, so it will be given the value of tiny. So let's run to that point. Make sure you have your run with feature caching turned on. We can run to this transformer and inspect it. And we can see we have our park area and the new value of park size. Let's take a look at the second example. I won't have you create it yourself. We'll go straight to it. So you can right click on this bookmark and enable all objects in the bookmark. Again, this is taking the parks, running it through an area calculator, and then looking up some conditionals. But this time the conditionals are a bit more complex. So now we're also considering the value of dog park. If dog park equals y and dog park equals y and value of park size is less than 2000, then it's a small dog park. So what we're looking at here is also making use of a published parameter. We're actually asking at runtime, are we considering dog parks? You'll also notice at the bottom here we're using a composite test. The pass criteria can be treat everything as an or treat everything as an and, or you can put together a composite test. If we have additional time today, I will also show a more advanced conditional example that makes more use of that composite test. So if we turn on this prompt and run up here, the question mark, and then go to run the workspace, notice we have type of park, dog parks or non-dog parks, on what it will calculate the values on. So if I want the dog parks, then we have the dog parks. No park size, unwanted park. There we are. So now we can see when I sort that we have large dog park, small dog park. If I run this again and change this so that I want the non-dog parks, notice it doesn't indicate that it's dog park anymore on that part of the translation. It simply does large park. Oh, no, wait, there we are, unwanted park. But it's going through the non-dog parks. And the dog parks are the unwanted parks. So these conditionals are very useful if you find yourself in a situation where you're looking at the attribute value mapper. That does a similar task, but it's really just looking up a single attribute. whereas this can consider multiple attributes. Okay, someone wanted a bit more of an explanation on the dog park parameter. It's possible to create parameters that prompt the user to provide a value. These are called publish parameters. And they'll show up here under user parameters. The publish parameters will show up when I have this prompt and run turned on and I run the translation. So I have these publish parameters. Your source and destination data sets, when you add a reader or a writer, are automatically published. If I happen to know that those will never change and I don't want the end user to change them, I can delete them. That does not delete the parameter itself. That parameter still exists here. It is simply no longer published. When I go to run the translation, I don't see that option. You can also create a user parameter manually, and then you can apply that to really any parameter which you find in the navigator. I can also create the parameters here. So let's say I have this multiplier. I can create a user parameter, and then when I run the translation, I can select at runtime what my multiplier should be. If I wanted to get really fancy with that multiplier, I could create a user parameter, use my favorite one, which is choice with alias. And then I can provide a value here. If I'm calculating my area in meters, the multiplier would be 1. If I'm calculating it in feet, it's 10 point something. I can't remember. We'll just pretend it's 10. Once I have that area units, I can then apply that to this multiplier. So I can unlink that, link to a user parameter, link to that one I just created, area unit. And when I run the translation, I'm prompted for my units, for my for my areas, and then I can choose either meters or feet. And that's what will be used for that multiplier. That's a quick overview of user parameters. They're covered in greater depth in the FME Advanced training course. Okay, let's move on to schema mapping and some of the transformers you'll end up using. First, we'll look at the database joiner. Actually, before we do that, I'll talk a high level about the database joiner, the feature merger, and the feature joiner. There are often situations where you would perhaps start with something like parks here and want to add additional attributes onto that parks based on something like a park ID, a unique ID attribute value. We may have additional information about these parks kept in another data set. There are 3 ways that we can join those attributes from another data set onto these features. Those are the database joiner, the feature merger, or the feature joiner. Which one you use depends largely on your data and where those additional attributes are being stored. If those additional attributes are in another database, the database joiner is an option. With the database joiner, I'll just connect this up here. A Parks feature will come into the database joiner, and in the configuration for the database joiner, I select the database, choose the table it's going to retrieve the additional attributes from, set my attribute mapping, or how they merge, what are the key fields. And then when I run the translation, a feature comes into the database joiner, it will make the request to the database, get the attributes, attach those to the features, and pass that feature out. So that's one way of retrieving the attributes. Another way of retrieving the attributes would be to read in that entire database table using another reader, and then feed these parks and that database table, those database table features, into a feature merger. Notice here we have a requester and a supplier. In the configuration here, again, we have a requester attribute, a supplier attribute, and then it takes the attributes from the database and attaches it onto my parks. The feature merger is largely replaced now by a new transformer called the feature joiner. The feature joiner, you may notice, instead of having requester and supplier, says left and right, but it works the same way. I have my requesting features, my parks, and then my database goes into the right. So this uses a left and right join. The difference between the feature merger and the feature joiner really comes down to two things. The first is that the feature joiner uses a more standard SQL nomenclature. If you are familiar with doing SQL joins, the inner, left, and full wording here makes a lot more sense, as opposed to requester and supplier. That's the first difference. The second difference is that the feature joiner uses some newer technology available in FME in the background, which is faster than what was available for the feature merger. So the feature joiner gives you better performance. It's a faster transformer. So if you've never used either of those before, I would probably argue with using the feature joiner instead of the feature merger. So then you're left with a question of, do I use a feature joiner or a database joiner? With a feature joiner, I have to read in that entire database table, feed it into this transformer, all those features will be stored in here, and then it will do the join. That is a considerable memory overhead. The database joiner does not have that memory overhead. In theory, the database joiner should be a faster transformer because it won't end up caching anything to disk if you have a large data volume. In practice, the feature joiner is often faster. And here's why. The database joiner, while it has low memory overhead, is performing a query of the database and getting the results back for each and every feature. And that query itself can take a considerable amount of time. So generally speaking, if the number of requesting features is similar to what's in your database, using a feature joiner and reading in that entire database table will give you, or most likely give you, better performance. However, if you have a very large database table and relatively few requesting features, then the database joiner will likely be faster, because then you don't have to read in all the features. It really comes down to the comparison of how fast you can make those queries for the number of features you have versus how fast you can read in the entire database table. There will be times where the only way you can find out is to actually try both of them and benchmark them. So let's open up the database joiner link. I'll send this out to everyone. Let's take a look at our database joiner transformer. So here we see an example where we're reading in address points. This would actually be a file geodatabase, but we have additional attributes available in a Postgres database. So we'll run the address points into our database joiner. We configure the database reader, select the table that has the additional attributes, postal address. We have the address ID, which is the attribute in our file geodatabase, and we match that up to what's in the destination table, the address ID in the Postgres postal addresses table. We can then choose which attributes to bring in. Again, if you have attributes which you don't need, keep in mind that those attributes do take up space in memory. So it's a good idea to limit what you retrieve or what you have going through your workspace to just what you need. And then when you run it, it'll read in those 13,000 features, and it will make a query for each of those features. We can see here that we have two output ports, joined and unjoined. The joined are the features that found a match in the database. The unjoined are the features that did not find a match in the database. So as to the question of whether or not it would be better to use the database joiner or a featured joiner in this situation, it's whether or not you can do these 13,000 queries of the database before you could read in our roughly 13,000 features which are currently in the database. In this situation here, I would bet that the featured joiner would be faster because it would make a single query of the database, get all those features back, and then do the join. But again, you wouldn't know for sure until you benchmark it. So let's take a look now at the feature merger and feature joiner. So let's take a look at the feature merger. We'll download the finished demo template. And I'll chat this out to everyone as well. Okay. So in this example here, we have GML geometry with additional attributes in an Excel spreadsheet. So we have our voting places and our Excel spreadsheet. Let me just run this part here. So our voting places, if we just run the voting places, we can then inspect that, and it looks like this. We have a number of points with a number of attributes. We then have this mayor Excel spreadsheet, which is non-spatial data. We can see division, voters, votes, blanks, overvotes, etc. So we have this division here. We want to take these voting results and attach them onto our GML points, which also have a division. Now, the database joiner in this situation might not work if the Excel spreadsheet is not considered a database. Now, I believe in the database joiner, Excel might be considered. Yes, there's a limited number of attributes here. Actually, it looks like it might read. No, it does not read all of them. Only the database formats, but sometimes we're rather flexible on what we consider a database. You'll notice in here that you will see things like a CSV file is considered a database as far as FME is concerned. But it's certainly not all the formats. So that's another example that if your data set which contains your additional attributes is not actually a database, then the database joiner would not work well. In our feature merger, we join on division for both of them. And when we run to this transformer, the feature merger, it gives us a number of results here. So we have multiple output ports. Merged are all the geometries that had a matching feature in the Excel spreadsheet. So I can see based on each division, I now have my voters, votes, blanks, overvotes, and undervotes. That was what was in the Excel spreadsheet. We also get a bit of feedback for things that don't match. And that can be really handy for further testing. We have our unmerged requester. These would be the GML points that did not have a match in the Excel spreadsheet. You may want to examine why that happened. We have our used suppliers, the features in the Excel spreadsheet that had a match or that matched up to a GML point. And the unused suppliers. There's more data in the Excel spreadsheet than we have in the GML file. So we can see here that we do have unused suppliers. These could be features which are outside this area of interest, or it could indicate that something's not quite right with your data. But ultimately, all this accomplished is it took the attributes from our Excel spreadsheet, joined them onto the GML points based on division. Now, someone had a question earlier about how do I connect to my database? If we choose something like a PostGIS database, it will ask for a connection. And then this will run you through a little dialog to add a database connection. Database connection information, the database server name, its location basically, your username and password, those are kept in an encrypted part of FME, the database connections. So I'd add or configure a database connection first, enter in the location of that database, my username, my password, and any other connection configuration that's required. Create that as a connection, and then I would use that connection information here. Okay, so we see that with the feature, or saw that with the feature merger. Let's take a look at it with the feature joiner. Let's open up the Parks Feature Joiner demo complete. I'll send that out to everyone. So in this example here, we have, again, our Map Info tab Parks. We also have a Parks dataset in a file geodatabase. And it contains some additional information like the park URL and park address. That information is not available in our Map Info tab Parks dataset. So we can join these attributes onto these parks using the park name. In this example, we'll use a join mode of left. Your options are inner, left, or full. If you want to do a right join, you're really just swapping the ports here. Now, if you're like me and have no idea really what left, inner, and full mean, there are descriptions of them in the help. It's important to remember that for all the transformers, there is a help document that you should probably review before you do too much with that transformer. And that will describe what the inner join, left join, and full join mean. So we're doing a left join. Attribute conflict resolution. If there are additional attributes here which match up to what we have here, let's say we did have a visitor count as well. If there's a visitor count here and a visitor count here, you can choose the attribute conflict resolution. You can use what's already on the feature, or you can use what's on the right feature. The same with geometry handling. If I have new geometry here, I could attach that instead, or aggregate them together. So now we run the translation to the feature joiner. We have what's joined and what's unjoined. Let's inspect that. These points here would be the unjoined. So these did not have a matching park. Okay, so that's the feature joiner. It's just a way of attaching attributes from one group of features onto other groups of features. Now we got a question here. This is a good one. Do the feature merger and feature joiner always add all fields from the join table? Can we just select the ones that we need? That's a good question. I've never tried to limit it before. Looks like the answer is no for the feature joiner. It will join all of the attributes. For the feature merger, let's see. Attribute accumulation. No, again, it looks like you cannot limit the number of attributes which are brought over from the other feature. With the database joiner, you can, and we saw that when it was configured. We have the fields to add. So when you're making the request to the database, if you leave this blank, it will bring in all of the fields, or you can select specifically which ones you want. Now, if there are attributes you don't want to bring over from parks, say I definitely don't want my park URL, just remember there are attribute manager transformers, or if you have a lot of attributes, you can use an attribute remover. The attribute remover transformer allows you to quickly remove attributes. Say I don't want my park URL or my object ID. Then I can remove those from the supplying features or the right-hand side of my join before it even gets into the transformer. Okay, so we just looked at using the database joiner, the feature merger, and the feature joiner for doing some schema mapping, reworking some attributes, or well, adding additional attributes onto a feature. We also have some other options here. The schema mapper. This can be really handy if you have an additional data set that provides additional attributes or different attribute values. So the schema mapper is a way of having an additional data set that can configure your output data, I guess would be a good way of putting it. Here's an example here. We have a data set which contains pipes. These pipes could be considered abandoned or active based on some conditions, which we will keep in an external file. So in our data set, it has a life cycle status attribute and an object ID. For our output, we want to test or filter based on the life cycle status. If the life cycle status is abandoned, then in the output, we will have an abandoned ID. We won't have an object ID, we'll only have an abandoned ID. and we want the object ID copied into that. If the life cycle status is active, then the object ID should be copied into an active ID. So let's take a look at this workspace. First of all, I'll send everyone out the link to this page. And the link to our workspace. So in this workspace, we have this water distribution main. We can run just this. For the output AutoCAD file, let's put that into FME data output training. Yeah, C FME data 2018 output training, and we'll call this just pipes.dwg. Well, hopefully she'll stop that soon. I think you guys could hear that. Okay. So we'll just run the source here, see what we have. So we have a number of pipes. They have a life cycle status and an object ID. The life cycle status options are active, null, or abandoned. So these ones without a life cycle status, we'll probably want to filter those out later on. Let's take a look at the schema mapper. The schema mapper is reading in a CSV file, this conditional attribute mapping.csv file. Notice on the schema mapper here we have the containing folder, so we can actually go to the containing folder for that and find that CSV file. And we can open that up. Let's open it up in Notepad++. If I right click on it, I can open that up in Notepad++. So we can see we have a filter attribute value, a source attribute, and a destination attribute. So the filtering attribute is life cycle status. The values, the possible values of life cycle status are abandoned or active. Depending on those values, we then take our source attribute, object ID, and copy that into a new attribute, abandoned ID or active ID. So this is essentially doing a conditional attribute value based on lifecycle status, but it's all configured within this external CSV file. So if this should change, or I want to add additional options later on, I don't actually have to go into my Workbench workspace. I don't have to edit my Workbench workspace at all. I only have to edit this CSV file. And we're not limited to just the CSV file. This could be a database table. This could be a Google Sheet. This could be pretty much anything. So in my schema mapper, I'm using a CSV file here. Notice under more formats, could be quite literally, well, looks like it sticks to the database formats, but also text files as well. You can see we have other cloud-based options as well, HTML tables. So we can use a number of things to configure this schema mapper. So you go to Next. The filter features we then configure, so we can edit this. So we have a filter attribute of lifecycle status. This is actually just showing me what we have in that CSV file. I'm not actually setting it here. Notice I can't click on anything there. That's all configured by what's up here. So it's just giving you a preview of what will be used. So my attribute name field is my filter attribute. That's in the CSV file. The attribute value field is the filter attribute value, which is either abandoned or active. And then we have the map attributes. So again, this is just giving me a preview of the results. This is what I actually configure it with. The source attribute field in my CSV file is called source attribute. My destination attribute is called destination attribute. We also have this option here, default value field. If it doesn't find a match, or if I have another default value, so if it can't match that up, I can set something here. The source attribute, in this case it's remove, so it will remove the object ID. It will no longer be on the feature. So let's run this through our schema mapper and see what we get. Now remember, we had some features that had a null value for the life cycle status. Those will come out through the unmapped here. So we can see life cycle status, those are all nulls. We could then handle those in some other way, add some additional tests, write that out to a file, and then send it through an emailer to email you it. Anything which you need to notify you that perhaps your data is incomplete. For the mapped, let's inspect that. Now you'll notice that I have my lifecycle status. The object ID, it's still defined here, but the value has been removed. So notice that there's no object IDs on any of those. My lifecycle status of active. Now I don't see the attribute that's been added. That's because even though we saw the attribute within the schema mapper itself, that's only because it was reading what's in the CSV file. So this doesn't actually know that I've added those abandoned ID or active ID. That's all information kept within the CSV file. The Workbench interface is unaware of that. So when I inspect the data, I don't see it in the table view because the table view only shows me the defined attributes. Also, that's why we see the object ID. The transformer itself is unaware that we've actually removed this. But if I select a feature, remember the feature information window gives you more complete information. In this, I can see all of my attributes. You'll notice that the object ID is not there. It is removed from the feature. And what I do have is my active ID. It's copied my object ID value into my active ID. So I have active IDs and abandoned IDs. Depending on which one I have, I'll want to write out to two different output layers, active and abandoned. I'll use an attribute filter transformer to do that. This is very similar to a tester transformer. The attribute filter takes a look at a specific attribute and then you supply the possible values, in this case active or abandoned. So we can run into the attribute filter and inspect our attribute filter. So we have our actives, see if I can get it to select something. There we are, active. If that doesn't move faster in a moment, I'll just skip over this part. Might be that I'm just running out of memory. Let me shut that down, reopen it. And something I should mention, if you are authoring your translation and inspecting your data often, keep in mind that each tab you have open is consuming a fair bit of memory, and you can end up running low on memory if you have too many tabs open here. Once you get to 10 to 20 tabs, it might be worthwhile closing the data inspector and then reopening it again later. There we go. So in my actives, I can see I have my active IDs, and in my abandoned, I have my abandoned ID. Now we can also add some additional information into that, some additional testing. That's the second example here, conditional attribute mappings using feature types. So just sent that out to everyone, open up that workspace. Oh, before we leave this workspace here, one of the things that you'll notice here is that we have this abandoned ID defined and active ID defined, and we've got this red triangle. Because the schema mapper is creating that attribute, but we don't actually see it anywhere, that's why we have red here. It's perfectly okay because we do have values for that. If the warning is annoying you, you could add something like the attribute exposer. The attribute exposer allows you to basically add attributes to the interface. Some transformers will create attributes where Workbench is kind of unaware of what's going to be created. But I can go in here and just specify it, active ID, abandoned ID, and that'll add or expose that attribute. It also means that if I run just to my attribute exposer and inspect it here, now in my table view, I will actually see those attributes, like abandoned ID, there, which I have values for some of them, and active ID, which I have values for others. Okay. Now, in this example here, before we were just looking up based on a particular attribute. Sometimes the information you want is actually stored as part of the feature type name, the layer name. We'll often see this with AutoCAD files or any sort of CAD drawing. Quite often the name of the layer is really important information, and you'll want to get access to that layer name. The name of the layer, the name of the feature type or feature class, is stored on the feature as an attribute called FME feature type. Now, depending on the transformer, some transformers have FME feature type available to select all the time. No matter what, you'll be able to find FME feature type because it's a really useful attribute. Other times it might not be available. Again, you could either use the attribute exposer to retrieve it, or if I go into the feature type itself and go to my format attributes, I can expose that particular format attribute, and then I'll be able to make use of it. So the FME feature type, that can be really handy. There are some other ones, depending on your source data, that you may find useful. In the past, I've also used FME base name. This is the base name without the extension of your source data set. So if you have a particular file that you're reading in and you want to make use of that file name, the FME base name can do that. Another option is to use FME dataset. FME dataset gives you the full path of your dataset, including the extension, but it'll also give you the folders that contain it. It's the absolute path. And then you can use something like a string searcher regular expression transformer. The string searcher transformer can do a regular expression search on a piece of text, or something like an attribute splitter to grab bits and pieces of your path. So in this situation here, we're going to be making use of the name of this feature type. Let's take a look at what it's using. So we have another CSV file. We can open that up in Notepad++. And we can see here that instead of using a filtering attribute, which is a user-defined attribute on the feature, we're making use of the FME feature type. Then we have the possible values: water distribution with control valve, water distribution with main. Then the sources, it's mapping two things this time. We're mapping our object ID to valve ID or object ID to pipe ID, but we're also mapping our diameter to a valve diameter or diameter to a pipe diameter. So before we were just copying a single attribute value across. Now we're mapping multiple attributes across. And again, you can manage all of that within your external CSV file. So when I run to this, let's give ourselves an output KML file, pipes.kml. And inspect that. Notice this time the object ID has been left alone. We'll take a look at the setup of the schema mapper in just a moment. We have our FME feature type. Now we've created things like valve, but that doesn't show up on the features itself. or it's not defined there, but we will find it here. There. So it's creating these valve, I believe it was diameter that we were creating. So let's take a look at the configuration of this schema mapper. So we're going to filter features, and we're also going to map the attributes. So at the filtering of the features, we have our FME feature type value, or the attribute that we're going to be checking, the possible values. Again, that's configured in the CSV file. And then the mapping part is configured here. So we're mapping our object ID to valve ID and our diameter to valve diameter, or if we have the other feature type, object ID to pipe ID and diameter to pipe diameter. So we're getting valve diameters and pipe diameters. And again, we attribute filter it again to separate them, and then write it out to two separate feature types. So that's the schema mapper. It allows you to maintain your mappings in an external file, which can make it a little bit easier to update your workspaces as time goes on. Now, sometimes a simpler way of doing that might be the attribute value mapper. I don't use the attribute value mapper much myself anymore. I kind of prefer the conditionals. Let's see if we have a complete workspace for this. It doesn't look like it does. But the way the attribute value mapper would work for this, let's see, is that a good example there? Well, let's give it a shot. Okay, so let's download the attribute CSV zip file. Oh, we're running into this problem. I think we have to skip this example entirely. Candace recently left SAFE, and that has a tendency to break links because she's no longer here, so that CSV file I can no longer access. Let's see if we can find a simple example of an attribute value mapper. Now this might work. The attribute value mapper is useful if we have particular values, a limited value or a limited number of particular values that we want to change. For example, in our parks data set, we have dog park, yes or no. Well, let's say we weren't filtering those out entirely, but I want to change that. Right now it's Y and N, and whatever I'm loading it into doesn't like Y or N. It wants specifically yes or no. So I can drop in an attribute value mapper. The source attribute is dog park. The destination attribute, I could copy this into a new attribute, or I can put it right back into dog park. A default value, if it's missing a value, what would I want this to be? If it's missing, it'll just be, say, no. We'll default to no. And then I have my source values. Y should become yes. N should become no. This is a fairly straightforward example. So now when I run this and inspect it, instead of Y's and N's for my dog park, now I have yes or no. So it's just taking your existing value and giving you a new one. Something which is handy with transformers like this, keep an eye out for the import button. In this example, I've only got two things to look up, yes or no. If I delete all that, something I can do to speed things up is import the possible values. Now this import could work kind of like the schema mapper, but as a one-time thing. So I can import the possible lookups. So I could import it from an external file which contains my lookups, say an Excel spreadsheet. But it can also save time if I don't have anything like that. I can have a map info tab file. I'll choose my data set, parks. It will read through that. So I tell it to read through parks. My source will be, oh, I filtered out dog park. Let's go back. It's my output. I need my input. Parks. So I have my dog park, and I'll map it to dog park as well. It cuts down the amount of typing by half. Oops, no, I want the actual values. Import from attribute values, there we are. Source value dog park, destination value dog park. Import, it reads through it and finds all the possible values. So then if I had, say, 50 of them, I don't have to type in the left-hand side. I'm just doing the mapping. So that can speed things up. And I still end up with my yes and no. So that's the attribute value mapper. Now the limitation of the attribute value mapper is it can't get any more complex, just looking at a value and that's it. Whereas the conditionals can be far more complex and even consider ranges of values. Now if you are also looking at ranges of values, there is also an attribute range mapper. And the attribute range mapper can consider ranges. But again, it's only the ranges of a single attribute, whereas the conditionals allow you to test against multiple attributes. For my purposes, I prefer the conditional values. Now, another thing I wanted to show, just briefly, just going to go to View Windows. We have our history. I'm just going to back this up a little bit. That looks like a good spot. Okay, so we have our tester here. There are alternatives to the tester. We've seen the attribute filter. The attribute filter looks at a specific value. Another handy one is the test filter. If you have a tester followed by another tester, that's an excellent example of where you might want to consider using the test filter instead. The test filter is basically a tester, else if, another tester, else if, another tester. Notice that this is the same interface as our conditional. I just can't add an output attribute value based on it. So if you have a tester followed by a tester followed by a tester, consider the test filter instead. This is basically a tester followed by a tester followed by a tester. If the outputs of those testers are an attribute creator, you want to create attributes based on it, then you really should consider the conditional values, because the conditional values is a test filter combined with an attribute creator. Okay, this brings us to some geometry handling. Before I do that, just a quick look at the questions panel. As I'm going through here today, I can't see the questions as they come in because on Mac, GoToWebinar broke the questions panel. So I have to sort of consult an external list, which I can only do on occasion here. So dynamically. Okay. So let's take a look at the point online overlayer. The point online overlayer takes points. Let's see if there's a better example here. Point online overlay. This is a transformer you will be using. It takes the points and intersects the lines with it. It will break the lines at those points, I believe, and it will also, yes, splits lines where they overlay points. It will also take the attributes from the points, copy them onto the lines, and the attributes from the lines and copy it onto the points. So the point online overlayer is a spatial join. Before, with the database joiner, the feature merger and the feature joiner, those were joins based on attributes. These overlayer transformers are joins based on geometry. Some things to consider when doing joins based on geometry. First of all, inspect the data, ensure that it's all in the same coordinate system. If you, for whatever reason, have ended up with a data set which is in a different coordinate system, you will have to run it through a reprojector in order to bring it into the same coordinate system. When you have the overlays, you could end up with multiple points on a single line. So if this is supposed to be copying your attributes from your point onto your line, which attribute will it bring over? Under attribute accumulation, actually this is something which has changed recently. By default, when you first drop in the point online overlayer, it won't bring over any attributes from one to the other. You have to tell it to merge the attributes. This is a change in behavior in FME 2018, perhaps 2017. I can't remember exactly when it changed. Older versions of FME by default would merge the attributes. Newer versions of FME, you have to go to attribute accumulation and tell it to merge the attributes. If you would have multiple points on a line, you then would want to create a list. A list is a numbered array of attributes. For example, here, if I had multiple attributes or multiple features, I have, say, a parcel name, but I also have tree species. In this parcel, I have multiple points, each one for a tree. I have a red spire pear, Chanticleer pear, and a flowering cherry. I have multiple points inside of my parcel. I want to be able to keep track of my tree species. It would bring them in as a list, or I can convert them to a list. So I have trees, and then in these brackets here would be the number for each overlapping point, my numbered array, my numbered list. So then it's able to store the attribute for each tree on this feature. Let's see if I can find the actual example of this. There we are, creating lists using transformers. There. Now this is using a point on area overlayer. It's essentially very similar in concept to the point on line overlayer. So let's take a look at park trees complete.fmwt. There we go. So all that really matters here is our point on area overlayer. Let's run to this deaggregator. Our parks dataset has a couple of aggregate features in it. These are multi-part geometry features. If you want to deal with each part of a multi-part geometry separately, you'll have to run it through a deaggregator. So we have our parks. Let's get our, in this case, postal addresses. So the postal addresses are then going through a joiner to retrieve information about trees. The trees, I guess, are kept in an external database. And it's a CSV file. So we have our postal addresses, and we have a tree ID. One thing you'll notice is that we actually have multiple trees per address. This is actually multiple copies of the same point. So when we do the overlap, there will be multiple points on each area. So in our point on area overlayer, we're overlaying these addresses onto the parks. We are accumulating the attributes. Notice this is an older version of our point on area overlayer. The attribute accumulation, it's always turned on, but we do have this generate list. So we're going to generate a list called trees. And it's going to contain all of the attributes from our points. So let's just run to the point on area overlayer and see what we have. So here's our areas. When I open this up, for some of these areas, I just got to find the right one. Maybe not. Just going to turn this on so I can spot the correct features. Oh, the parcels are pretty small. That's the issue. But this guy right here should have them. Okay, just have to see where this is. Okay. So there's an example, and we can see that on this particular feature, this one only has a single tree. Gotta find ones with multiple trees. This may not have been the greatest example to show. So it looks like we only have a few that have multiple trees. Ah, here we go. Finally. So this particular one here had multiple points within the park. Each of those points will be stored as a numbered list that contains all of the attributes of that point. That way we can keep track of all of the attributes. This is important because we don't want to lose that information. So here we have trees 0, trees 1. In this case, there's only the 2 trees. Now, once you've created the list, there's a number of things that you can do with it. There are a number of list handling transformers. So some things that we could do, we could explode the list. This is creating, right now, a polygon with one list attribute on it. What I could do is explode this list. It'll create a feature for each list element. So I could create copies of this area. The list indexer, I could grab a particular list element and promote those attributes to be the main attribute. List element counter. The list element counter counts how many elements there are and stores that as an attribute. That actually might be handy here. So if I have a list element counter, I can take my trees and count how many matches I have. So I have my element count, sort this. There we are. There's a feature with 8 trees on it. So I can see my list here. So it's storing all that information. The list histogrammer can find the most common values. So if I wanted to promote the element with the most trees, so if I wanted to do basically a statistical analysis, what is the most common tree on this parcel? I could run it through the list histogrammer, and it'll give me the counts. And then I can promote list histogram 0. That would be the most common one in this example right here. Some other things we can do, we can concatenate together the elements of the list. If I just want a comma-separated value of all of the tree genuses or names, I can use a list concatenator. I can also create lists using a list builder, and I can also sort lists with a list sorter. So once you've created a list, there's a number of things that you can do with it. Let's continue on down through our list here. Let's see what creating lists using transformers example 2. No, we're going to skip that one. Some additional transformers that you will be using in the workspaces. One is the spatial relator. The spatial relator does an analysis of the spatial relationships of features. So we have a requester and a supplier, and what it calculates is the kind of spatial relationship that the requester and the supplier have, crosses, intersects, etc. This is different from other transformers like a spatial filter, which actually filter the features, or the overlayers, which will intersect features. The clipper also intersects features. So these two transformers here, the overlayers, not just the point on area, but line on line, all of the various overlayer transformers, and the clipper transformer, those will actually change the geometry of the features, or can change the geometry of the features. Point on area is not going to, but area on area certainly can. For what you're going to be working with, the various line on area, line on line, point on line overlayers, those will have changes to the geometry. The clipper changes the geometry as well. The spatial filter does not change the geometry. Features either pass or fail. The spatial relator transformer simply adds the spatial relationship as an attribute. You can almost think of the spatial filter as a spatial relator followed by a test filter, which can then test the various relationships and filter based on those. If you're ever curious about these relationships, crosses versus intersects, we do have here the spatial relationships defined. Intersects, disjoint, equals, touches, all the various types of tests that can be performed or reported on. The topology builder builds some topology information. For example, creating nodes, and here you can see we have lines and nodes, and it'll add attributes of the lines that come into the nodes, and the nodes are the points that are on each line. So that's the topology builder. Notice that the topology builder has multiple outputs. What you put in, it'll then create these various features. Transformers like the clipper, the spatial filter, and the various overlayers, those will do spatial joins of attributes, but it requires that the features overlap. Sometimes you want to grab features that don't quite overlap. In those situations, the neighbor finder is very useful. The neighbor finder will find the candidates within a specified distance of your base features. Now, that does require that you have bases and candidates. Sometimes you only have a single group of data, your candidates, and you want to find the closest candidate to each candidate. There is a candidates only mode as well, which can help with that. On occasion, when there have been situations, I'm not sure if you'll run into this, there is another type of neighbor finder, the neighbor pair finder. This finds the two closest features to each base, or sorry, each candidate. I have trouble remembering which way those goes. Two closest bases to each candidate. No, two closest candidates to each base. In situations like that, remember, the help documentation is very handy. There we are. It'll find the closest candidates to each base. Now, sometimes your points and your lines might not be close enough together to perform these spatial relationships or these spatial comparisons. You may need to clean the data a little bit by snapping them. There is the snapper transformer, but another transformer to consider is the anchored snapper. The snapper just snaps all the features that are close together. But sometimes you want a particular anchor to stay put, to stay where it is, and make sure that everything just snaps to that. This example here, we have a number of points. We want to snap them to the line. If I just ran this through a snapper, it could be going in either direction. With this example here, the line is anchored, so then the points snap onto the line. And that's the anchored snapper transformer. We have the anchors and we have the candidates. The anchor in this situation would be the line, the candidates are the points. Someone says, is it possible to snap a line to points? Yes. Make the points the anchor. and then snap the line to it. The clipper transformer is also a useful way of clipping out areas of interest. And it will also copy attributes from one to the other. In this example here, we have building footprints and parks. We want to clip the building footprint out of the park. So the building footprint is the clipper, the parks are the clippee. I usually think of it as cookie cutter and cookie. So then you can clip a part out of another feature. Let's take a look at this as a template. So I just sent that off to everyone. Let's take a look at what we have. So we can run our building footprints. And then we'll run our parks. Uh-oh. Oh, this is something which you may see from time to time. I was hoping that would show up. This line here in the log file. Optimizing memory usage. This means that I've run low on memory on my system. When FME is running the translation, it will start caching features to disk. Sometimes that takes a very long time. In situations where you see this, optimizing memory usage, chances are the culprit is your data inspector. Remember, as you have the various tabs open, they are eating up a fair bit of memory. Closing that will free up the memory. But it's also important to note that it won't actually change the settings within this translation run. If I free up that memory, FME doesn't really know that's happened. It checked on available memory at the beginning. It's set some limits for when it'll cache to disk, and now it's running with those limits. So if you free up the memory and the translation is still running, it's often fastest to stop the translation and then run the translation again. In this case, it looks like I'm probably got the memory somewhere else. Oh, well, it's probably because I have a whole lot of workbenches open as well. Okay, so let's inspect these two here. Remember, if you wanted to inspect two particular features with your partial runs, you can select them and inspect those cached features. If you find that you're doing that quite often with two objects or multiple objects on your canvas, another thing to consider is putting a bookmark around them. Inputs. Notice that the bookmark has a cache as well. So I can just inspect the cache features of that bookmark and get both of those. So now you can see that I have many building footprints inside of my parks. I want to clip those building footprints out of my park. So my building footprints are my clippers. The parks are the clippies. I then have what's inside and what's outside. So if I inspect what's outside, I can see I now have my parks, and it has a lot of little holes where the building footprints are, like so. This can also be used as a spatial join. My clippy inside, clippy outside. Right there, I'm looking at what's left of the parks. On the inside, these are actually what's inside my building footprint. So if I look at my building footprints here, I actually have no attributes for my building footprint. So this would be a way of finding my building footprints and what park those buildings are within. So here's my building footprints. Let me turn off the background map so I can see them more clearly. And in each building footprint, I can see what park that building is within. Okay, another note for performance. Let's see if I can find a better workspace for this. Let's do this one here. This is the workspace we were using yesterday, our dog parks one. We had the filter data part of the translation, and then we moved on to statistics calculation. I'll put a bookmark around to that. Statistics and labels. Now, if I run this translation with my feature caching turned on, actually, first of all, let's see how long it takes with feature caching turned off. Remember, the feature caching gives you a considerable performance hit. It's worthwhile when you're still actively putting down the transformers, because then I'm only running some small part of the translation. But when I go to run the entire translation, it's a considerable performance hit. Without my feature caching turned on, this translation took 4 seconds. I'm going to turn the feature caching on and run the entire translation again. So last time it took 4 seconds. With feature caching turned on, 3.8. I hate it when that happens with the small translations. I've only got 73 features, so it's not giving me the best results here. Let's see if I can fake this a little bit. I'm going to put it in a cloner. I'm going to create 1,000. Let's go for 1,000 features. That might be excessive. And we'll see how long this takes now. So let's turn that off, run this again. The number of features just wasn't sufficient. So this should create around 80,000 features. So you can see it's taking a little bit longer this time. There we go. I also have that optimizer going. I'm going to close down some of the other workspaces because that's probably eating up some memory. There. Now, hopefully that's freed up enough memory so I can get an accurate timing for how long this takes. Maybe not 1,000 times, let's just do it 500 times. I'll watch for the optimizing memory. This is just intermediate processing. That's fine. There, so that took 29 seconds. Let's turn on the feature caching. So it was 29 seconds before. So this time we're not seeing the memory issue. So that took more than twice as long. So that's why it's a good idea to turn off the feature caching. But there is one other thing you can do if you don't want to turn off feature caching. You want to make use of this the entire way through. It's important to note that the feature caching only caches features for the output ports of transformers. More accurately, it only caches features for output ports. We saw briefly yesterday that you can collapse your bookmarks. Here, I have 4 output ports. This is all my data filtering portion. If I collapse this, I only have 1 output port. Similarly over here, I have 1, 2, 3, 4, 5 output ports. Again, I can collapse this and bring that down to 2. So then when the translation is run, instead of caching at every single transformer port, it only caches at the output ports of my collapsed bookmarks. So this is why bookmarks are really handy when authoring your workspace. It collects transformers which are doing a specific task together, and you can find those bookmarks in the navigator. So if I'm looking for a particular part of my workspace, I can find that part of my workspace quickly and easily. So that's one thing which bookmarks really help with. Also, as my workspace becomes larger and larger, the bookmarks make it easy to move sections of my workspace around, to make space for other parts of the translation I need to work on. So the bookmarks also keep your workspace organized. And finally, when I collapse them, it improves the performance of my translation when I have feature caching turned on. Basically split the difference here. Without feature caching turned on, it took 30 seconds. With it turned on, but the bookmarks open, it took over a minute. Now it's taking 44 seconds. So that's a considerable performance improvement. And one of the things that you're going to be dealing with is very large volumes of data. So if you have the feature caching turned on, but put things in the bookmarks, that can speed up how long it takes to run your test translations. There are some other things that you may want to consider also when running your test translations. Limiting your data volume. One thing which you can do is if you're reading in a huge data set, perhaps clip the data. You can do that in a number of places. You could use transformers and then cache the features at that clip and then just use that little area of interest from there on out. So you would never run the translation by running the entire translation. You would make sure that your feature caching is turned on and then just run from after your clip. So using a clipper and an area of interest polygon would help. Another option is to pass that clip to the reader itself. In the readers, we have our parameters and there's a search envelope. And you can tell it to only read in within that search envelope. You have to enter in the X and Y values manually, but that way you can just read in a subset of your data. There's also a features to read here. You can tell it to just read in the first 1,000 features, but for what you'll likely be doing, that might not work very well because you just end up with a random assortment of features spatially. And they'll be all over the place. So you might not get the translation working the way that you expect. Now, this might be an option if you have the data sequenced spatially, I guess. But for the most part, the search envelope or using a clipper transformer, caching it up at that point and then continuing would work well. Now, another thing about the caches, these caches only exist when I'm working on this workspace. But it is possible to save your caches. Now, if I'm working on this workspace and I close the workspace, those caches are gone. They are temporary. But if I've put in these bookmarks and I go up to File, Save as Template, this will save it as a new file, but it will include my caches. So if I know that I'm going to be working on this again tomorrow, and I want to save my caches, I can save this as a template. I'd save it onto, say, my desktop. And I would choose Include Feature Caches. And the next time I open up that template, it will save my caches. Just keep in mind that with templates, when you open it up, it hasn't actually saved that workspace. I have to make sure that I save that, and it's not saving it back to the template. The template is just a template. It's a starting point. When I open up that template again, I then have to make sure that I save my workspace. And at the end of that day, if I want to save my caches again, then I have to create a new template. Okay, so we've seen the clipper, list transformers. I've talked about the list histogrammer. Does a statistical analysis of your list and tells you the most common list element value. List sorter sorts your lists alphabetically or numerically. List element counter, we saw that when I counted the number of trees in a polygon, counts up the list elements. List searcher will look for a specific value in a list and then returns the index of that. You can then use the list indexer to promote that particular list element to be the main values. Final two transformers, the variable setter and variable retriever. The variable setter and variable retriever are a way of setting essentially a global variable that can be used elsewhere in a workspace. So I can use a variable setter here. This will create a global variable, and I can give it a value. I can then use that elsewhere. Let me get rid of this cloner here so this goes quickly again. Variable retriever. And that'll save it as value. So when I run this translation, the variable setter will set that value. Now it can be something that I set directly, or it can be based on an attribute itself. And then coming out of the variable retriever, I end up with that actual value. So here's my variable retriever. I'll see that I have an attribute, a value with hello. But in the intermediate stages, I don't actually have that. Something's making the data inspector unhappy. Might have to close it. There we are. So I don't actually have that attribute. Now in this situation here, this isn't the way you would probably do it. What you would generally have is data coming in from somewhere else. But I want to attach it. This is kind of like the value mapper, or not the value mapper, the feature joiner. I want to take an attribute from one data set and attach it somewhere else. But I might be doing it in a way where they're not actually interacting in any way, shape, or form. So when I run this, I'm creating a feature, setting the variable. And then this one here, even though it's not connected in any way, it should be grabbing that value. There we are, my value, hello. So it's a way of setting a global variable for the entire workspace. The only thing to be careful of is when this is actually being set. Sometimes the read orders can mess things up a little bit. For example, if I set this creator to create at end, let's see if that'll actually still set it. That'll create it towards the end of the translation. It might not actually get here in time. No, it did. Let's put this earlier in the workspace. So I'll take my variable retriever. So that was going through a statistics calculator earlier. If I set it here and run the workspace, it should create that at the end. And when I inspect this now, I have no value. So this was being set after this had finished reading in. So it's important to watch out for the sequence like that. There is a way around that. There's a transformer called the feature holder. It holds back the features. So everything will be read in, this will be created, this will hold the features, hopefully long enough, and then it'll go through the variable retriever. Fingers crossed, let's hope this actually worked. There we are. So the feature holder can help with the sequencing.